Hello, everybody. Welcome back to Flight Simulation Association and our upcoming webinar on building your own home cockpit. And my name is Evan. Hopefully you folks recognize me as the co-founder of Flight Simulation Association, and you may also recognize some of the folks sharing the screen with me here today. If you were at our show in San Diego, whether it was in person or whether you watched it online, both Trevor and Sebastian were part of that show talking about the subject that we're just about to dive into, which is building your own home cockpit components, something that has become much more popular and prominent within our community over the past couple of years as 3D printing and the whole do-it-yourself movement has really come up on YouTube and just across basically the whole world. We're seeing that coming into flight simulation as well. So they're going to take us through a deep dive of something that literally I've been interested in and will learn more about along with you. I'm going to ask plenty of dumb questions, and I encourage you guys to ask all your questions over the next day today, and of course as we go into part 2 of this seminar, which happens next weekend. Now, I just want to get started by talking about and acknowledging the invasion of Ukraine and what's happening in Russia and Ukraine. That's something that, of course, is affecting our entire flight simulation world and the whole world, in fact. Obviously, we know we have simmers that are from around the world who are members who may be participating today, may be impacted by this in ways that, for me sitting here in North America, I certainly wouldn't have imagined possible given the day and age that at least I thought we were in. So for everyone who is impacted, of course, our thoughts are with them, and we hope for the speediest possible ceasefire, recovery, whatever possible solution there could be at this stage, so that isn't happening anymore. And for anyone who may be impacted by that, or we know plenty of people, developers in our sim community who have teams that are affected by this, obviously our thoughts are with those people, and the fact that we're quite privileged to be here talking about flight sim and how we can improve our setups in the context of what all is happening in the world right now. So with that being said, let's talk about what it is we're here to talk about today, and that being home cockpit building and the components that we can use to help make our simulator experience that much better. Now, some people may be thinking about getting into this because maybe you want to build a specific part, so there isn't anything commercially available. You've looked at Thrustmaster and Turtle Beach and Honeycomb and some of those big commercial producers, but maybe there's a specific part that you want to create, something that isn't out there. Or as I said before, maybe the whole do-it-yourself movement sort of resonates with you. We're hoping that this is sort of the first step on a potential journey for you to get into this really cool, fascinating, do-it-yourself, hands-on experience of home flight simulation, home cockpit building. So we've got lots of ways you can be watching today and participating today. You may be watching on the Flight Sim Association YouTube, Facebook Live. We are live on YouTube with Captain Bob and on the MobiFlight channel and on Skyblue Radio as well. So please ask your questions no matter where you're watching. I'm in the Skyblue Radio DJ chat. Of course, I'm watching all of those YouTube comments. So as you have questions, fire those through. If you're an FSA captain, right through our live chat, and if you're a first officer, send those questions in through our website, and we'll pass those on to Trevor and to Sebastian over the next hour and a half. Now, we're live right now today for part 1 of a 2-part series. Coming up, part 2 is next weekend, so the 19th of March. Today, we're going to look at basically the first component of this, so designing, thinking about what's out there, and kind of planning out your build. And then part 2, we're actually literally going to build something live for you on the screen. And you can actually take part in that if you want by, well, just going right here to this website, captainbobsim.com/flaps2022, and you can actually literally get the parts list that we're going to be using. You could order those parts and you could literally build along with us if you wanted to. And Trevor and Sebastian are going to talk all about that as we get going. So I guess before we start, we're supposed to talk about, Trevor, this new word that you're trying to coin. Is that right?
Yes, I think it's already kind of a word, but it's not official. Home cockpit. Should it be one word or 2 words? And
That's
is
a
there a
great
better
question.
word?
So if you guys can comment in the chat, we'll do a straw poll, and as they're talking in the next little bit here, I'll try and collect some responses. But the question is it supposed to be home cockpit, just like he has on the screen up there as all one word? Should it be home space cockpit, the way that we put it out when we made this webinar? Or is there a better word that we can use? So put your thoughts in the chat wherever you're watching, or in the Skyblue Radio Discord, or on our website. Send those things through, and I'll collect a little bit of a straw poll of our viewers, and we'll see what people have to say. With that background, that'll keep me busy, so I'll send things over to Trevor and Sebastian. Trevor, please take it away.
Absolutely. So we're here today to make a little tiny flaps lever for your simulator. I have one right here. Connects through Arduino, and it allows you to change your flaps position. So we're here today with myself and Sebastian from MobiFlight. So,
Hey guys, hello. Thanks, Evan, for your kind introduction and great words and good overview. So really happy to be here. Thanks for having us.
yeah. So, oh, so yeah, the flaps, captainbobsim.com/flaps2022 is where you'll find all of the sources to everything. I have the STLs linked to the Thingiverse. We have drawings, we have cutouts, all the links to everything. The link is always in this bottom corner right here, so you can find it easily. So, as for myself, I'm Captain Bob. I'm Trevor. I'm a high schooler that loves to build home cockpits. I like the engineering aspect of it. And I started about 2018, so I've been in it for a few years. I have a YouTube channel and a tiny little company that makes flight simulators. You can check them out at captainbobsim.com. And I also started the Cessna 172 project that's building parts of simulators like these flap handles. I'm building yokes and everything like that. All of the plans I share online at the GitHub too. And part of my kind of story is that I didn't meet the colorblindness standards for night flight, but I really liked engineering, so I decided to kind of pivot from being a pilot to really learning about airplane systems and being an engineer. So yeah.
Super cool. Yeah, cool guys. Yeah, so then I'll introduce myself also real quick. My name is Sebastian. I'm the MobiFlight creator, main contributor, developer. I have started MobiFlight, I believe it was back in 2014. And I'm really an aviation enthusiast. I'm super. I'm super thrilled by aviation. I actually hold a commercial pilot license. In real life, I'm not. I'm not a commercial pilot, but I mean, I've done that. I have an instrument rating. I also have a European private pilot license. I'm a little older than Captain Bob, 42 years old. Yeah, I'm an IT guy. I got a computer science degree many years ago. And kind of that's probably also why it allowed me to create MobiFlight and these kind of things. And yeah, as I already said, I'm an aviation and flight sim enthusiast. Flight simulation was definitely the entry for me, or to get closer to aviation again, because when I was a kid, it felt like something like totally unachievable and very, very far from reality, or not achievable. And then yeah, through flight simulation, and I kind of found my way back into aviation, which is super, super cool. I'm also a big fan of open source, which means that you share your intellectual property with others, and you allow others to participate and contribute and make it better as a group. And that's something that I also do with MobiFlight. And that's also something that I would love to point out, because MobiFlight, as you can see, I have a very active community on the Discord channel. I put a link up there. Also, please sign up. It's really, really great. There's so much knowledge in this group of people, and a lot of them are sharing their their thoughts and their experience with each other. And some of them also help me to actually develop MobiFlight and make it with every version a little better. Yeah, so that's me.
And by the way, a couple of early responses on the straw poll here, and please put your comments in, folks, as you're watching. Is it home space cockpit or home cockpit, all one word, or do you have another? Maybe you have another name that you'd like to propose. So far, I've gotten a nice middle ground response. FSA Captain Patrick
Really?
says home dash cockpit. I think that's a bit of a cop out, if I'm honest, but there you go. That's a good way to build some compromise. Steve comes up with one that I haven't heard for a while, which is SimPit. Do you remember when everyone was saying SimPit?
Yeah.
Yeah,
That
it's
kind of
not
went
bad.
away. Yeah.
It's cool.
I heard Michael on our YouTube said home flight deck. And QB says
That's a
home
good one.
sim. Both spaces though,
Homestead.
so I'm not getting much love for the all one
Um,
word Trevor. I'm sorry, but we'll see. There's still time.
there's
I
still
have
time.
one word also on my like that was my preference too. It's on my
Yeah.
sweater.
Oh, so many things I
Okay,
guess.
so now we have to come up with HomePit.
I guess so.
Yeah, I think I used a different one for like every slide because this one has 2 words with each letter capitalized, so or 1 word with each capitalized. Yeah. So
All right.
definitely. Uh, so for this webinar, we're going to be doing the design requirements behind building this. We're going to talk about like how we designed it, what we need it for, like what its requirements are, how it was created, and we'll just kind of run through those a little bit to make sure they're all like we understand everything about this panel. So next week, we'll be actually building it. So we'll screw it together. We have the 3D printed parts here that will show you how to combine them into a flaps module, show you how to wire it, any like special little steps. And then after that, we'll configure it to show you how to get software to talk to the simulator.
Using
So
MobiFlight, the easy
exactly.
part.
Yeah, yeah, it's all fun and games. And it's not actually that hard. Um, we're going to be building a flaps module. The Cessna 172 SP is the specific version I like went all I could for. We're going to build, I tried to match the colors and everything and the template. You're getting a little bit of glare, but it should be matched as close to 1-to-1 as possible. It even has a little servo that goes up and down.
It looks really cool. Nice work. It looks cool.
Thank you. Let's see. So here's a video of it actually in progress to prove it's not just like a replica. It actually works with the flight simulator. So when you move it down, the servo follows and tells you what position you're at. So that's really handy. You can use it and then you won't have any conflicts to tell like what flap position you're at, where you have like an up or down one. You sometimes forget what position flaps you're at, but with this one, it tells you so you can just look down and read it. It's really nice. Not again. There we go. So my intention with this was to just have something that I can fly with. So I have like, so when I'm just gonna hop on a flight, I'll have one monitor with my like altimeter motives panel here, a honeycomb yoke with all the switches, and then the flaps panel. And I found without this flaps panel, I would have to like go to the keyboard, but this just removed most of the things I reach for the keyboard too. So that was really handy for me.
Yeah, that's I mean that's one of the motivations, right? To build your own stuff that you can get really rid of mouse and keyboard interactions because that's like a big immersion breaker. Every time that yeah, I mean it's like you have to look around and then you leave the context of the sim and then you have to find your mouse and it's kind of once
Yeah.
you have experienced like it is what it is without it, it's so much fun, right?
Exactly. It's awesome to just reach over and click the flaps button instead of having to like remember, I think like F2 or something, something like that. But yeah, I'm sure seeing this happen, you're pretty overwhelmed. You're like, there are wires coming from this, and there's like this input output card thing we've never seen before. There are like these 3D printed parts, and then you like design it and put this like all of these magical box things together. It can be super overwhelming at first, but our hopes are that we can break it down to a level where we can help you to see that it's not rocket science. And you can even do something a little bit simpler. I have just a tiny switch right here. This should be a 3-position switch. It's a 2-position switch, but you can have it say, okay, when it's in the middle, let's see if we can balance it. When it's in the middle, the flaps aren't doing anything. When it goes up, the flaps should go up 1 notch. And when it goes down, the the flaps should go down one notch. So you can have just like a piece of wood and a little switch to do that. So you can really start like that. So
Yeah, I'll just say some words to this maybe real quick. So yeah, I mean, you might wonder now, okay, like Trevor is showing us this wonderful piece of technology with all those wires hanging down, and so I have these switches, and maybe you also have some lights or LEDs or whatever other things that you would like to connect to your simulator, and you're asking yourself, so well, how do I do that? I mean, I'm not a electronic engineer. You're probably not an IT specialist. Who can code stuff, and so there must be something in between that connects that helps you connect the physical hardware with your virtual flight sim environment, and that is actually where also MobiFlight comes in. So if you go to the next page, we have the I/O card, which is the blue card that Trevor just held up. It's called an Arduino card, for example. Yeah, that's capable of receiving inputs, electrical signals, and convert them into digital information, as well as you can also send information to them and, for example, make an LED light turn on or turn off. And then you also need something on your PC side, because the flight sim cannot directly talk to this card, to this input-output card. And again, yeah, this is, if you advance to the next slide. So here, the main pieces that actually help you do this is first Arduino, which is an open source hardware platform, which comes with a lot of different devices types. Some are more capable, some are a little less capable, but overall they are very achievable. They're you can buy them on Amazon. You can buy them on the internet, and they're not really expensive. You know, they something between $10 to $30 or so, and they allow you to get started. And MobiFlight being the connecting piece, which now knows how to talk specifically to the I/O Arduino cards, and at the same time collect the data from your flight sim. Let's say, for example, the current flaps position, or maybe your landing gear position or something, and sends this information to the I/O card, as well as when you hit the button, when you flip the switch, then it can translate this information into something that makes something happen in the sim. And the good thing about this, first, I already said it, it's open source. That's really cool. So you can also contribute. You can adapt it to your own needs if that was really necessary. MobiFlight is also freely available for download. And the really cool thing is you do not have to know how to code at all. So this is very intuitive, and we will see that then next week in our session when we're actually going to configure stuff.
Absolutely. I really like MobiFlight. It's pretty easy to use for everything. So it's really, when I discovered it, I was so excited to see the link between like physical hardware and then the simulator. It was awesome. So for this webinar,
Trevor, if you don't
we're going
mind,
to...
Evan here, I was going to jump into a couple questions.
Perfect.
We got a couple already, and I'm sure there will be more where those came from. And friendly reminder, wherever you're watching, post your questions. We love questions. I'm sure Sebastian and Trevor will be happy to answer everything you can throw at them. So whether you're watching on YouTube, on Facebook Live, or our website, fire those questions at the chat, and I will make sure to catch them all and do my best to forward them all onward. So a couple of questions. These are, I think, more general for you guys to just answer as best you can. Brett is wondering, where can you buy and sell parts? So maybe you've created your own part and you want to try and sell it, or maybe you're looking to buy like a, I don't know, 737 throttle. Any thoughts on where people can buy and sell stuff like that? Any marketplaces you guys know about?
Well, you want to go first, or I go first?
You can go first.
Yeah, so there are some shops available on the internet that have specialized for kind of selling these kind of things. So they basically give you pre-made panels or so that you still have to connect, like the wires, and so you have to take care of that. But the appearance and the design and like the the look and feel of everything ranges from like from authentic to almost like a 100% replica, and the prices can also vary a lot for those. So
Mhm.
yeah, you have to kind of pay something for it since they're not made, like it's not a mass product. At the same time, for example, if you are into like do it yourself DIY, then I believe Trevor is anyways going to talk about some places where you can
Mhm.
find information that's helpful. And also there's communities like on the MobiFlight community, we actually started to also share designs with each other, which then require some hardware, for example, like a 3D printer that Trevor is also going to introduce later in this webinar,
Mhm.
to produce them themselves for yourself.
Absolutely. Some of my places I look are like eBay. You can sometimes find people just like building a few like flaps panels or something, or like switch panels, and you can find them online. I have my store at captainbobsim.com/shop. I sell things. There's like flight sim stuff that sells like the little throttle propeller throttle mixture. A few companies like that. Um, and yeah, you you can also find marketplaces online, and sometimes uh, you can just like word of mouth find someone that like sells flight simulators through communities.
I
So
even
yeah,
have one.
that's
And I never have answers for these webinars, so I even have an answer. One's called ineedsimparts.com.
oh nice.
ineedsimparts.com, which is run by a guy who did a webinar on here, Tony. And so that one's mostly like airliner parts, so like real 737, A3 like 20 parts that people literally pull out of scrapyards. That's a website you can consider for that. And there's a couple other ones like that out there, and I think maybe Cockpit Builders Forum also has a place where you can buy and sell stuff, I think. Someone could correct me if
Yeah,
I'm wrong. Noster on I think on the Captain Bob YouTube says he's ordering their first Arduino today, so that's awesome to
oh,
hear.
that's so exciting.
Yeah.
Yeah, do it. Go for it. And
Question.
by
Sorry, go
the
ahead.
way, just to make clear that there's original Arduinos and there is also clones, so-called clones, since the idea behind Arduino is also open source. So they shared actually everything that you need to know to replicate those. And so there's also so-called clones, and they're a lot cheaper than the original ones, and they also work uh, very, very well.
Mhm.
So obviously, it's better for the original project if you go out and buy an original board. But yeah, if you can't break, or if you had to break the bank for that, then you can also go for the clone ones.
Perfect. Couple more MobiFlight questions for you, Sebastian. Will it work with X-Plane 10?
Yeah, it does. It's like I'm saying, there's also a lot of presets that come for X-Plane 10. The integration with Microsoft Flight Simulator 2020, I would say, is currently a lot better. But if you join, for example, the Discord, there's also really very friendly and knowledgeable people around. So if you can get started, or if you have trouble starting out, then just reach out there and get some support. But yeah, it is possible to use it with X-Plane.
And one more MobiFlight question before we dive back in. Can MobiFlight be used remotely in a second PC so you could, for example, have all your hardware plugged into one PC but be running the simulator on another one?
Yes, that is also typically possible. Yeah.
Okay.
So in the past, MobiFlight relied a lot on FSU IPC as being the main interface to the sims. And FSU IPC also supports this network connections. Now for Microsoft Flight Simulator 2020, we have a more direct integration with SimConnect. So FSU IPC is not necessarily needed anymore for the Microsoft Flight Simulator 2020. And there we have the SimConnect capabilities also allow you to configure it so that you can use it over the network.
Perfect. Okay. Just keep sending me your questions. I will keep track of them. And Trevor, back to you.
Absolutely. Thank you for your questions. So today we're going to go over a little bit of the design process. So my design process, this isn't like officially written through like an engineer with a PhD, but my design process is to go from idea to research and images to 2D drawings to CAD. I feel like that's just my best workflow. So I start out with an idea. So I'll brainstorm like, what do I want? Like, how should it be? I'll kind of get a sketch pad, maybe like write out a few ideas, and I'll just ask myself, what do I want? How do I want it to look? Like, how do I want it to feel? How do I want it to be? And then why? Like, why am I doing this? And it's always helpful for me to ask why, because sometimes I'll like go down a rabbit hole fixing something that isn't important. Like if you're working with VR, your flaps panel might look a little bit different. With VR, you wouldn't have to have this indicator because the indicator would be in the VR cockpit. And you wouldn't have to spend like the 3 hours I spent designing this paper, the decal. So VR simpits sometimes, oh no, I said simpit, maybe Homecockpit. VR like Homecockpit, simpits, they sometimes have it easy because you can, if you know the why behind it, you can skip steps that don't mean anything.
I also have a recommendation for the what. So if you are doing your next flight, just like have a pen and paper next to you, and every time that you have to like reach to your mouse or your keyboard and you interact with your virtual cockpit without, because you don't have a button assigned on your yoke or so, just like write it down and tally it, and then at the end of your flight you will see what you have done most, or like you can actually count and see what are very frequent interactions where you have to switch the context from flying to grabbing your mouse and looking for the right keyboard button or so.
That's a great idea. Yeah, I've never thought about that, but that's awesome. Yeah, and that can help you decide which thing to target first, which is really powerful.
Yep.
So I figured out all of this. I wrote down these questions, and I said, we want to make a replica Cessna 172 SP flaps panel. I was like, I want that one because that's my simulator. I'm basically building mine to be a replica Cessna 172 SP analog. And it needs to be something that uses Arduino technology, so these input-output cards, and I want to have open source software. I chose to not go with something closed source because with something closed source, if the project dies, no one can carry it up. So that was important for me. And I need something that's approachable for a beginner, so it can't deal with like zeroing the like a stepper motor, like crazy Hall effect sensors. It needs to have a pretty simple mechanism, so it's not like putting together like hundreds of pieces. And it needs to use off-the-shelf components and 3D printed parts. So all of this is 3D printed or 2D printed in the case of the decal. And then this is an RC servo, so one off of like an RC plane. This is a pretty standard Arduino potentiometer. And then we just use like a tiny spring right here and some connectors that are pretty standard. So that is, you can find all of these parts at Amazon. You can get either like a friend, or sometimes a library has 3D printers, or you can like order it from online from a service, or even ask in the community if someone would be able to ship it to you. I also wanted this to be pretty cheap and easy, so it could be approachable. So when I did all of this research and images, I researched different variations, operations, and I just tried to get my mind in the heads of the engineers at Cessna. So I looked through a bunch of YouTube videos to find like this person was doing a pre-flight in a Cessna 172. I took a screenshot to see like what it would look like at different points in its use. I looked at a few eBay pictures of flaps faceplates. I looked at the real part from an airplane just to kind of like get an idea of what it's like. And I think I found a pretty good solution that I'm pretty proud of. I then went into 2D drawings. So I took it from an idea to something concrete on paper. So this is what the drawing might look like, just a rough, ugly sketch about like how everything will fit together, kind of like what thicknesses I should use, where everything will be placed, how it will be placed, and maybe some dimensions that I can use later in the design process. Here's this one I had to like recreate because I accidentally threw it away. This one is an actual drawing. This is like a little radio stack mounting panel that I was like, okay, this is how I could get it to work, and I could use like wing nuts or something. So 2D drawings for me are really helpful to not put the cart in front of the horse. Yeah, and then after that, it's taken into computer-aided design. So usually I have my 2D drawing, and I'll just kind of like, I feel like whenever I'm doing it, I'm Tony Stark, and I'm like, whoa, doing all sorts of crazy stuff. But in reality, I'm just like drawing a little line, giving it thickness, or extruding it, drawing another line, extruding it, and then like kind of working out where it goes. There is a pretty steep learning curve to CAD. A lot of times, sometimes you'll like not be able to know how to make something. So there are tons of tutorials that I'll talk to you later about where you can find them. So after a few hours, usually it starts to look like something awesome. So you can see see it grow over here. So then you have it all designed and you're ready to 3D print it. So when I did design this, I actually designed 2 versions of it. I'll show you this one. This one is the potentiometer design. You can see right here, it's very smooth, and then you click it down, and then it goes back up. This is preferable because the real Cessna 172 is more realistic to this than it is to the switch right here. Also, this switch in the presentation, this switch here doesn't mesh well with the panel, so there's not really a great way to cut it out. Also, it also looks a little cheesy because the flaps handle travels like 90 degrees to hit all 4 switches. This one, I think, only travels like 30 or so. So this one just looks a little more believable. So this one was our winner. It's more realistic, fits better into a panel, easier to configure, and it can be used for a lot of different types of planes, which makes it a lot better.
Couple
This
quick
rotary
questions.
switch.
Sorry, Trevor, a
Oh,
couple quick questions for you
yes.
that are just right on the design piece. From First Officer Tony, he wants to know, when you're designing these components, how much are you able to get of the real world mechanics and internals? Can you, for example, find the designs available online, or do you try and sort of recreate it yourself? And you talked about that a little bit, but can you just remind us how that all works?
Oh, so there are some designs you can find online for like super common components. I think like Dark Arrow 1 has a few components that they're trying to CAD model and give away for free to help like home builders for actual airplanes, and you can just drag and drop those. I haven't really found those, very many of those that are useful for home cockpit builders. And there are also, but other than that, there aren't that many CAD drawings per se of like, or CAD files that you can just drag and drop and modify. So usually I'm taking a look at dimensions from like people with measuring tapes, holding them up to simulators, which are awesome for designing. I love those so much. Or you're just kind of guessing dimensions you don't have. Like this flaps handle, I think I had a length, but I didn't have a thickness. So I used a few images and kind of had to piece together my best like width and kind of like see how it looks. So there's no magic catalog of everything like you kind of think there would be. but you can kind of piece together what you have and go from there. So yeah, that's a great question.
I
Perfect.
would also like to add a little bit from my experience, because I also believe it's a great question. I think a lot of the times I think we are recreating those from scratch with some ideas that we're trying to come up with. And this is also sometimes because not all the mechanics are, even if we knew how it worked, then you still wouldn't be able to just get them somewhere and buy them, because those switches are very special and they're, aviation grade, and then you cannot afford them because they're super expensive or simply not available. Like as an example, I always see people also on our Discord, the A320 FCU, yeah, where you have this pull and the push in kind of these switches. And oh, there are so many ideas around this topic, for example, of how to best achieve it. And I think it's also part of the hobby, or maybe it's a hobby inside of the hobby. That this becomes part of something that you find as a challenging task, and actually a fun task though, to recreate something like that and make it behave, look, and feel authentic.
Excellent.
Definitely.
Matthew, I've got your question. I will bring that up in a couple minutes. Gabriel from our Facebook page says, thanks for sharing your knowledge and hello from Niagara Falls, Ontario, Canada. Not too far from where I am, so hello. And
Nice.
great name on Trevor Captain Bob's YouTube channel, Planes, Trains, and Automobiles. It's going to be one of the best
Oh,
YouTube names I've
hey.
seen for a while. He says, hey, Trevor, great to see all of your innovations.
Oh, yeah. Oh, trains, planes, and automobiles. I
Yes.
recognize him.
And a
That's awesome.
question from First Officer Brad, and I just want to make this clear to everybody. We've talked about it a couple times, but just in case you missed it, Brad is wondering, have we put out a parts list and a source? Yes,
Ah,
absolutely. So I just put it on the screen there for everyone to see. CaptainBobSim.com/Flaps 2022 has the whole parts list, and I think Trevor, you can correct me, but you can basically buy the whole thing as a kit right from Trevor's
mhm.
website if you want to, or you can basically go source all those components yourself on Amazon, eBay, wherever you can find them. Even maybe your local hardware store might have a few. Is that right?
That's correct. Yep, you can
Perfect.
buy a whole kit or just them individually from like Amazon.
Good stuff. Okay, Matthew, I've got your question. We'll come back to that, but guys, I'll let you continue on.
Absolutely. Fantastic. So with the rotary switch, um, we didn't really like it. It's clicky, and that's probably good for VR where you can't see what position it's at. So you're like, okay, is this like that position from the top? But we decided it would be better to do the potentiometer just because you'd have like that more like smooth travel of like if you're doing the flaps. So this one is our winner. We kind of just scrapped this rotary switch one, even though you can technically still do it with all of my parts. I released the files anyway. So whichever one you choose, we're just going to focus on the potentiometer one. So as I was saying, Fusion 360, I would recommend it as a CAD software. They have a personal plan. It is a bit limited. You can only have like 5 active files, and you have to figure out how to do that intelligently. But you can use it like as a student. I think there's a startup license, and so I think it's a really powerful CAD program, and I would recommend it. So
Yeah, just to make it clear, like there is this hobbyist license that you can have if you don't make any money off this. So this is for free an entire year, and then you have to renew it. But I've never hit any limitations, and I'm also using it. It's a great tool. I totally
mhm,
agree, Trevor. It's an awesome tool.
yeah. I love using it so much. So a few of the people and you can take a screenshot of this if you want to learn Fusion 360. A few of the people that I learned Fusion 360 from are this guy Kevin Kennedy, I think, from Product Design Online. He does a ton of tutorials about like a lot of the like more simple, like how do you make a sketch, or like how do you use the extrude feature, to like videos that take you through the whole design process of like a table. I think this is one of his videos. There are videos from Brad Tallis, and I really love his videos because they're just like a 12-hour series about like, I think one of them was a pencil sharpener. So you can just, for like 12 hours, sit with a professional, someone that works at Autodesk, and sit with him and design a pencil sharpener, design gears, and have everything work together. That's how I've learned a lot of really smart stuff with Fusion 360. And then there's also someone I learned from, Lars Christiansen. He has a great YouTube channel with a lot of Fusion 360 tutorials. So yeah, there's a little bit of a learning curve, and maybe you don't start out with like crazy designs. Maybe you just start out designing something like this, with like mounting holes that you can 3D print for a flap switch. If it takes too long and is too frustrating to get complicated designs, it's usually easier to start simple. And of course, there's also always the option to not learn CAD yet. I would recommend at least learning a little bit of CAD. So if there is a CAD model design out there that you need to tweak a little bit, you can kind of like make your own adjustments to it. So like, say if you had this model and I have the step file to this, so you can import it to a CAD program. You could say like, I only want this faceplate. I'm going to chop it off right here, delete everything up from there. That's a lot easier than, I don't know, pausing the printer when it gets to that height. So it's great to learn CAD, and you can also download pre-made, ready to fly models that you just print, build, and go. So there's Thingiverse, GrabCAD, Prusa printers, I think, and then things.com. So these are my favorite places to go for this type of thing.
Yeah. Hey, just a question to you. Maybe it's also a question for some others on who are watching. So first of all, like these STLs, yeah, right? Those are the files that are needed to actually kind of take your model and be able to print it, or there's an extra step in between. But anyways, like it's a generic 3D model file. But it sounds like that for all these things that we're looking at, it would require a 3D printer to actually print them. Or what about CNC or laser cutters? Those are also very kind of heavily used or very popular in the community at the moment, right?
Absolutely. Yeah. CNC mills and laser engravers are really popular, so you can make whenever possible, I try to kind of design for both. So this design, if I did design it for CNC and a laser printer, it would have had this faceplate as one piece, this side as one piece, and then the other side as another piece. And maybe you'd like tap a screw or something in so that you could tighten them all up. So yeah, there's these STLs are usually for 3D printers, but you also have files like SVGs and DXFs that you can use with laser engravers. And I have like a switch panel that I used with a laser engraver. So you can do, usually there are a lot of other types of printing too, or not types, but yeah. So that's really awesome to see. And it's great to see like all of the potential that comes behind open source and like sharing your designs. Oh, there we go. So after I'm done with the first design, I have a CAD model of it and everything. We'll go through a little process that makes it better. So I go through what I call a prototyping cycle. I'm sure other people call it that too. I basically prototype it, print it, and assemble it. I'll have something, I don't have any, I do. I have an early prototype. You can see right here. Its hole is in the wrong space. This one doesn't fit very well. It's too short right here. It's not curvy enough here. It was kind of sharp. I didn't like that. So I kind of just went through this and fixed it up. and I figured out the method for my paper. It didn't really work that great because it would peel off, so I ended up like laminating. So I learned a lot from this. This was my test after assembly. I felt how everything functions, and then I basically wrote down all my observations on just like a little piece of paper right here. I have a little notebook that I just write everything in. So
I sometimes watch people on the internet, and I kind of really envy them. It almost looks like they come up with the first prototype that they make. It's already perfect. Never happens to me. I
no.
always screw something up, so I always have to go back into the Fusion 360 software, make some changes, and then print it out. And that's like a little bit the cumbersome part of 3D printing, is that it can really take a long time, even for smaller pieces. So this prototyping cycle, sometimes between test and refine or so, that you have to wait simply some hours until you actually can get it. And then even on the second try, it happens to me so many times that I just forgot something again and doesn't work or doesn't fit.
Definitely. I really sometimes I skimp too on the right part of things. I'll just be like, it doesn't need to. I don't need. I'll remember that, and then I forget. I kick
Do you
myself
also
every time.
do you also have that sometimes you tend to make things too complicated?
Yeah,
Or you make
definitely.
like super complicated construction, and then it just, I don't know, it won't work
More
because
work.
it's
Yep.
simply too complex.
hmm
Or another thing that has that happened to you, Captain Bob, or I say Trevor, has that happened to you, that the 3D program like Fusion 360, you can zoom in so far in that your things that your design, it looks so big. Yeah, you think like,
Yeah.
oh, I have to nudge it over by a half of a millimeter, and like it still looks like there's like a huge sidestep or so, but in reality, it's so, everything is so tiny, and you
Uh,
print it, and then you figure out, oh my god, that's so small. I totally designed that the wrong way because my hands are too big. I cannot even use this or whatever.
yeah, it's so funny, the designs from like CAD to real life, because I have a few designs right here. I have a whole bag actually of parts. This is just proof that it takes a while to get parts to work. I had a like pretty simple idea. It's 3 pieces, just this little shell, a nut, and then a little piece that goes inside here. And I thought I would get it first try, but it took me like five versions of it. I even have them like labeled right here. I just have version after version where I like, that doesn't work. Nope, not even close. And then yeah, I definitely overcomplicate or like don't think about it. So sometimes the prototyping cycle, you like nail it and just need to like add a screw hole that's a little thicker or something. But sometimes you're like 10 versions in and you're like, why is this still not working? But yeah, definitely it does vary, I would say. Yeah. So after I write everything down, I'll go into refining it. So that's kind of what we said, and then just repeat it until I'm satisfied with what I have. So yeah, that is the prototyping cycle. It sometimes looks a little different than depending on your part, but I really like it. It's fun to like see what you can challenge yourself to do. So with materials you can definitely, if you're not careful, you can get really into the weeds. Sometimes you'll be like, okay, this is something I could use, but it's not really that like sourceable, or it's hard to get. So materials is for like something I'm sharing. I used PLA filament. It's a pretty standard filament. There's also like ABS, but you can print it with whatever material you want. I just chose PLA because it's accessible and pretty easy to print with. Um, that's not actually the part I needed, but I was also thinking about maybe like a different potentiometer some type of mechanism there, but everything else was just like too complicated. And if that one like seller somewhere went out of business, then the whole design wouldn't work. So usually with materials, I try to make them pretty standard and easy to use. So for these, we touched on PLA. I use different colors to get the different colors, but you can also just paint it if you want. Potentiometer, it gives kind of the fine axis. A servo to tell you what position you're at, and then some metric screws. You'll also need an Arduino Mega. That's the input and output card. I would just say get a Mega. They're a few dollars extra than an Uno, but they give you so many pins compared to an Arduino Uno. And you'll also just need a tiny little small spring. So yeah.
And that is a perfect time to ask Matthew's question. Matthew, first officer on Flight Sim Association, was asking about that spring. He wanted to know what size spring would be required, or if you give any more detail on that.
Yeah, I have that. I'm going to go into my... Actually, I have the spring box right here. I don't know it off the top of my head, even though I just ordered some. It's a compression spring that is 3/8 of an inch by 5/8 of an inch. So it's this one. I don't know if you can see that. Probably not. It also looks a little blurry. Oh, that's funny. It crawled up the green screen. So that's the size of the spring. I'll make sure to update the website with the spring size so that you don't get the wrong one. I'm sure you could like mangle a pen's spring because it's also a compression spring into the right size. But getting the right size is definitely the easiest solution. I just bought a little spring assortment. It was like $10, and then I have enough springs for all of my flight simulator projects. And I might need to order like a few of a specific one, but you can just like try around and look for the best one. So that's what I would recommend, just so you have like enough springs for forever. Fantastic. Yeah, thank you for the question. I totally forgot about that. So there are always like people that with every single thing I do on YouTube, they'll just be like, why didn't you do it this way? So I like to explain why I didn't use like a stepper motor for this servo. This servo can be pretty jittery. So why am I using a servo? They kind of like jitter a little bit, but I really wanted to use a servo just because it's pretty simple. 3 wires instead of like 6, less potential for mistakes. Also, this has a specific range, like 0 degrees to 180 degrees. But with the stepper motor, there are stepper motors that go like for infinity. So I didn't want to introduce the potential to like break your little needle when you like set the stepper wrong or something. So we don't want to have to zero the stepper motor in at the top and then like deal with unzeroing it if anything happens, or like adding a zero mechanism. And then why didn't we go with a Hall effect sensor for this potentiometer? This potentiometer, a lot of people like to give them a bad rap because they're friction, or they're basically like contact components. So you physically like turn the potentiometer, and after like years of use, they can kind of wear out if you use them a lot. But I went with a potentiometer, so I didn't have to deal with Hall effect sensor magnets or any like magnetic effects, just for like a relatively beginner aimed project. And I also just wanted it to be compact and simple. But yeah, if you have any reasons why I should use something else, put them in the comments. I love learning from your feedback, or like if you have any cool new thing that I can use. That's always appreciated.
Yeah.
So, Sebastian, do you want to talk about this?
This or just what you said before? Because I think the choice is great, what you did. I think the servo, as you already said, only 1 pin. It's super simple to wire. And the potentiometer, it's also very accessible. You know, you can get it everywhere. Maybe Hall sensor is a little bit harder to get and harder to work with. So yeah, cool. What are our problems? Our sim only knows values. How do we tell the board what to do, and how do we tell the servo what to do from the simulator data? Yeah, that's I mean, that's also exactly where MobiFlight comes into play. And we will have a really, really deep dive and very close look into that next week with the next session. So yeah, we have to tell, for example, if we talk about the position of this little pin that indicates the flap, we have to be able to read this value from the sim, send it down to the Arduino board, and then make the servo move. And the other one, like that would be the output direction, so to speak. Yeah, putting the value from the flight sim out to some form of device, which is the servo. And then we have also this input device where we have our potentiometer that we manipulate. So we're actually creating the signal from the potentiometer and then send this over to the sim so that we're back in sync. So we tell the sim there with the input device, hey, this is the position that we have put it now in real world, and you have to follow this. So from a kind of interaction pattern, output devices, when we read, the leading system is going to be the sim. And for the input data, it's kind of our physical hardware is the ones where we generate the signals and have the sim follow what we tell the sim.
Definitely.
Does that make sense?
Yes.
We probably should have drawn a picture or something. But I hope
yeah,
it
I
makes
should have.
sense.
There's so much like space right here for like
Yeah.
at least a meme or something. But yeah.
Put Homer there.
Yeah. Basically, it's basically like MobiFlight soaks up information and gives out information, kind of, or like it knows what the flap position is, and it tells the simulator that, and then it knows what it like grabs information from the simulator and shoots that out into our servo. So it's kind of cool how like MobiFlight acts as that step between them. Oh yeah, there's the right way. So how do we do that? We solve our problem with these fancy Arduino chips that we've been talking about this whole time. Look at that. So these are little tiny microcontrollers. That's basically the best way to describe them. They control a bunch of things through these pins. So they can turn things on and off. They can read if it's on and off. And you basically, it's kind of like a little computer that you hook up to your main computer, and everything does its stuff in here. It's the magic box, if you want to think of it like that. But there are a lot of things similar with these two Raspberry Pis. If you've ever worked with those for like a sprinkler project or like some crazy potato cannon or something, you basically just have a bunch of input and output pins, and you wire electronics to them to control things. If you've ever used those. So these are super awesome. They're also open source, which makes them super awesome, and a lot of support for them.
Yeah, so just to add to this, like the Arduino itself doesn't know anything about what these pins mean, right? It's really up to you to decide what you would like to connect and to which pin you are going to connect it. And that's really also the philosophy that MobiFlight or that was driving me. I always wanted that it is super flexible with MobiFlight, and that it's not coming, as a prepared board where you can say, oh, from pin 10 to 13 you can attach buttons, and from 22 to 30 you can use LEDs. No, it's like with MobiFlight, it's super configurable. You can put up to 68 buttons onto that board, or maybe you decide, no, I want just 30 buttons and another 20 LEDs and 2 servos, and you can configure that all interactively through the MobiFlight software without having to know how to code. And it's very intuitive. At least I'm trying to make it very intuitive for everyone so that this this hurdle, you know, that you have to overcome, that this initial barrier is really, really low, because if you had to deal with all the internals that MobiFlight takes care of, it would be super overwhelming. And I mean, I've been doing this now for the last 8 years, and it's probably would be really, really hard for you to spend another 8 years of effort into getting to the point where MobiFlight is right now.
Definitely. Yeah. It's super awesome to be able to like click a few buttons and get everything to work. So it's if you had to write everything like connect this to this and like it would be crazy. So it's really nice to have the Arduino connected with MobiFlight. And the next material or electronic we can learn a little bit about, just a brief introduction, is the potentiometer. So I don't know if, yeah, here it is. It basically sensing the position more or less of the flaps handle so that it basically gives you a tiny little range of flaps movement. So if you think about it, it's kind of a three terminal variable resistor. It gives a certain like ohms reading, and it changes a voltage from basically 0 or off to on, and on for 5 volts, and it basically gives you like a range, and that's interpreted by the Arduino. It's converted to a digital signal, and then it's like a value between 0 and 1023, to give it a certain amount of bits.
Okay, good.
Okay, bits, I think. And then
10 bits, sorry. Yeah. We
10
have a
bits.
resolution of 10 bits for the
Mhm.
Arduino. So if there's other boards that have higher resolution, but we get like a number between 0 to 1023, anything in between, depending on the current position of your potentiometer. Yeah, that's correct.
Yeah.
And then we can and then we can take this value, you know, like 0 or 10, anything in between, and send it to the flight sim. And that's what we're also going to see next week. And it's actually super, super easy. Might
Mhm.
sound confusing at the moment, but
Yeah.
it's really cool.
And then basically it's like gives it a certain resistance. So it's really cool to see it, like see how it also oh yeah, that's what I was gonna say. You also have resources in the captainbobsim.com/flaps2022 that just like kind of explain how a potentiometer works if you're curious. But also if you're not curious and just kind of want to go along with the flow, that's okay too. So you can learn more at captainbobsim.com/flaps2022. I have a few videos and resources on that blog post.
And
Next.
just to make another connection for the guys who are watching, like your joysticks, they work
Oh
with the
yeah.
same thing. You know, your joystick axis, when you go forward, backward, you're basically moving a potentiometer back and forth, and
Yeah.
that's translated into this information that is sent to your computer.
Definitely. I forgot about that. Okay, so yeah, in the flaps diagram, you can see that the potentiometer is just right here. It's what gives it the signal. So the next thing we have is the servo. So these also, if you think about it, they have an internal potentiometer that basically tells what position it's at so that it can make sure to be where it's supposed to be. And then it has a little tiny motor. You can't really, or you have to like zoom in more than I can to like see how it all works. But basically, if you like were to take it apart or look at a video of someone else taking it apart, there's a tiny little motor that spins one way or the other way. And then depending on where it thinks it is, it tries to go to where it should be. So that's basically kind of how these work. They use one input and output pin, and then they just have like 5 volts and a ground, or ground and 5 volts. But yeah, these are what I started using as my first input and output. They're pretty awesome. They're also used as a connection to like the control surfaces on the RC plane. So you can see it go like left and right for the rudder, and you can see these usually being used by servos. So this is where the servo is. It's the blue thing. It's pretty awesome. So as we talked about, to design everything, Fusion 360 is what I used for CAD. It's super powerful. I love it because you can make parameters and reference them and use a lot of cool features. Some free alternatives to it are FreeCAD, Tinkercad, and Blender. FreeCAD would probably be the best alternative. Tinkercad is super awesome if you're a beginner and you want to just like dip your toes in a little. I wouldn't stay at Tinkercad too long like I did because it's really aimed for beginners and you don't have a lot of nice features that are nice to have. You have to do everything manually with cubes and stuff. And then after that, it's Blender. And Blender is really great if you want to like design yolks and stuff that are very organic shapes, but I would probably stay away from it a little bit if you're mostly just using like engineering computer-aided design instead of like artistic modeling.
And FSA Captain Patrick, he suggested as an alternative also Onshape. I don't know if you guys have heard of that at all.
Onshape, yes. Onshape is a great alternative. There's the free plan that makes everything you use open source. So if you are like, if you're okay with everything being shared with the community, Onshape is a great CAD program. Yeah, thanks for the question or the suggestion. That's another great one. I didn't think about that. Inkscape is what I used to design the little faceplate, the decal. It's so shiny right now. Yeah, to get all of the numbers and it's upside down. The numbers and lettering, and it's all vector based, so it's a scalable vector image or graphic, so you can scale it infinitely. You can use it with laser engravers. I try to make most of my stuff with Inkscape so that laser engravers can use it if they want to. And a paid alternative to Inkscape is Illustrator or Corel Draw. So those two are very nice.
And First Officer Tony wants to know what you think about SketchUp.
SketchUp. I've used SketchUp. I don't pay for it, or like I haven't paid for it, and so I haven't used it since it's been free. I've dabbled a little bit in it since it went online, but I haven't used it mostly because I get a lot of satisfaction like when I'm using Fusion 360 and I can like make it all look really realistic. I think that's just a little tiny thing. It was actually
I would also like to add to this real quick, if I may, because I used to use SketchUp a lot back, like maybe like 4 or 5 years ago. And then one of my coworkers actually he introduced me to Fusion 360, and I was literally really blown away, because there is one thing that Fusion 360 really can do. Has first of all, it's parametric modeling. That means you can use variables and put numbers in it, and kind of your model will then adjust. You can reference those. So it's really, really, really super cool. And and also like with these constraints that you can work with, it's really, really cool. But there's also this timeline that Fusion 360 has that SketchUp does not have. So with Fusion 360, I can always go back in history with all the steps and modifications that I have done to my model, and I can make a change to those, and then it replays the rest of the steps. Like, I can then go back forward in history again, so back to the future, and then all my other steps will be applied on top of the modified thing. And since it's all parametric, and so it's so cool, it's so powerful, I don't want to miss it anymore. So I've done a lot in SketchUp. I really have to say Fusion 360 is by many ways better than SketchUp.
I also think it just looks a little prettier. It's kind of like
Yeah, I mean, SketchUp has a great benefit. It's like super easy. It's very intuitive, and maybe Fusion 360 at the beginning might look a little overwhelming, as you said. Definitely. It has a steep learning curve to it, but if you watch some of those YouTube videos and you understand what the philosophy is behind Fusion 360, you don't want to miss it anymore. It's so cool.
I love working with Fusion 360. A lot of I'm working with an airspeed indicator right now, and the timeline is so helpful because I can go back in time and say, oops, I used the wrong screw. That was a mistake. And I can just make it a little bigger and everything's fine. It trickles down to the future and usually doesn't have too many errors. So it like usually works pretty well to like make an early design change and then like go to the future. That's also really what let me make if I go way back in time to the back, hey, this is a timeline. If I designed 2 options in one file, and this was super awesome because it let me like copy this one file, make a copy of it, but the copy is moved, but the copy is also linked to the first copy. So if I make this look like a rubber duck, the rotary switch one will also look like a rubber duck. So they both like
Oh, rubber duck. Why would you? That's the funny thing. Let's put a rubber
yeah.
duck in our home cockpit.
If someone's good at Blender, you should make a rubber duck flaps handle. That would be great. But if you want to make a change to one, it makes a change to the other. And that's what let me, the power of this like modeling and the like power of the CAD let me make this version and this version with the same file, just like different, like, and it's all linked and everything. So that was really awesome.
I've already got a flux capacitor joke on the MobiFlight YouTube channel. Pizman82 says, "Back to the Future. Check the flux I think he says condensator, but I'm thinking he means capacitor. I don't know. I'm not an expert on my Back to the Future." And Patrick, FSA Captain, also points out OpenSCAD, I think, is another option.
Oh yeah,
Yeah,
I've heard of that one.
More for the programmers, he says.
OpenSCAD, that's the one where you have to basically program
That's what he was saying, yeah.
your 3D model. Yeah, it's really powerful in the sense that you can work very precisely also, but I believe just my personal opinion is that since it's really about coding, and so I think many people are probably left out a little, and Fusion 360 might be more approachable for them because it's like this 3D interactivity that you have. You see what you get, basically.
Mm-hmm. I think I'm on the wrong slide. Let me get... There we go. That's where I am. So those are really what I used to design it all. It's pretty awesome. But manufacturing-wise, you're probably all, if you like are going to make the jump to make a 3D, to like buy a 3D printer, first of all, congratulations. It's super exciting. But if you're
So
like new
cool.
to 3D printing, I would recommend the fantastic Authenticate webinar. He did a webinar about like everything to know about 3D printing, what printer you might want to get, how to slice everything, a little bit on design. So that's just a well-rounded like flight simulator 3D printing. 3D printing. I guess it's a webinar. So you can find the link to my Flaps post, my Flaps files in the post. It's captainbobsim.com/flaps2022. If that's not drilled into your head already, but you can find it on Thingiverse, and then I just pulled it into Kira, and this is how I sliced everything. I didn't do anything fancy to the flaps except rotate the face to the bottom. Didn't do anything fancy to these, no supports or anything. But for the flaps handle, I used a 5mm wide raft and some supports touching the build plate. So that's basically it. I used an infill of 25% because when I'm like dealing with my home cockpit, usually I want to keep the cost down a little bit. I used a layer height of 0.2, and there's not really any supports needed there. So 3D printing, I tried to like design it to be pretty easy to 3D print. So yeah. So I think that's about everything with this. So now go get your parts and get started. What are you waiting for? Who's got this? You got this. You can do it. So a little checklist would be to purchase the electronics, print your 3D parts, 3D printed parts, and download MobiFlight from MobiFlight.com. That'll just make you as ready as possible for the next webinar where we actually build it. So that's everything from that we have here.
Yeah, I really love this. You got this kind of slogan. It's really something that drives me. I think really that also I know, Trevor, we're kind of really encouraging everyone to just try it, and it's actually easier to get things to work than it might look at the in the beginning. So just try it, give it a try. Failing just makes you get more experience, and then you become better, right? And I think it's a very, very satisfying experience when you have something built yourself, and it might be just like a very easy button box or so, a box with buttons that you can flip the switch on your desk and it actually does something in the flight sim. It's a super rewarding experience, I would say. And it's actually easier to get there than you might think.
And I think that's one of the really cool things just about flight simulation in general is there's so many unique parts of the community. Like every time I do one of these webinars, I'm discovering that there's another community that I either didn't know about or like I kind of knew it existed, but it was like, okay, I thought maybe a couple people did this, right? So this is another great example of that where it's something that you've not on your own. Like you're not just trying to do this and YouTube is all you've got. There's so many Discords. Here's two of them that we're looking at right now where you can just go in and post your questions. It's so much easier now to get started on this kind of thing. And Sebastian, it was 8 years ago when you would have been starting it, I'm sure. So we got a bunch of questions. For people who have those questions, friendly reminder, if you're watching on YouTube, put it in your channel chat. If you are watching on the Flight Sim Association website and you're a captain, put it in the live chat. If you are a first officer, send it on through and I will ask those questions. We've got about 15 minutes, so lots of time if you have any questions left over. Now, friendly reminder, this was part 1. So next weekend on Saturday the 19th, we do part 2 of this webinar. And so in part 2, we are literally going to actually build this for you, like right in front of you on the screen. Trevor's going to literally do this, right, Trevor?
Yes, absolutely.
And
I have
so
my screwdrivers all laid out.
so we're gonna literally do this live next weekend, and you want to join us for that. Now, because of a quirk, remember public service announcement here that at least where I am in North America, the clocks are changing tonight into tomorrow morning. So it's at 3 o'clock Eastern, which is the same time if you happen to be in North America's Eastern time zone. However, it is a different time if your clocks don't change tomorrow. So if the easiest way is probably just to go to our website, flightsimiassociation.com/webinars, and you'll see the time in GMT if you're not logged in, or if you have a free account, you'll actually see the time in exactly your own time zone, so you don't have to worry about the math. And if you register for the webinar, which again is totally free, you get a handy little calendar invitation that shows up at exactly the time it's supposed to be at. So we don't have to do any math, which as a pilot I appreciate not having to worry about. So let me go pull some questions, guys, and we will ask as much as we have. And don't forget to join us on March the 19th. Sebastian, I've gotten lots of questions about MobiFlight, what it works with, what it doesn't work with, so I'm going to put you on the hot seat with that. And maybe the easiest is just to explain which simulators MobiFlight can connect with, and if there's some limitations, for example, they need to use FSUIPC or XUIPC, stuff like that, and then I'll maybe ask a few more follow-ups depending on how much you can cover.
Yeah, sure. So yeah, basically the main flight sims work with it. So Microsoft Flight Simulator 2020, there's a really cool, nice integration with that that I've added to MobiFlight a year ago or 1.5 years ago, 1.5 years ago. But also before Microsoft Flight Simulator, as I already said, MobiFlight is around for 7-8 years. At least. So we have support for FSX, for FS9, for FSX, for Prepared 3D, for X-Plane. And back in before Microsoft Flight Simulator 2020, MobiFlight was using FSUIPC as a common interface or an FSUIPC-alike API. So for X-Plane, there is another plugin called XPUIPC, which is made for X-Plane, but kind of behaves as if it was FSU IPC in the regular Microsoft Sims. So yeah, I hope that helped. I hope that answered the question. Basically everything, basically every flight sim, but we don't have support for DCS really. And what's the open source one?
Flight
Gear. Thank you. That one not.
Okay, and how about IL2 Sturmovik? I'm assuming not as well.
Yeah. I mean, you can use it for inputs if the key press, for example, works, or if you use MobiFlight, used to be, or should be compatible with VJoy. Now I'm probably promoting something that is currently broken at the moment. We're going to work and hopefully be able to fix that. But yeah, that's some like it's kind of a fallback option, but it would not give you read access to anything in the sim, which is kind of really would be a disadvantage. Yeah.
For FSX and for P3D, can it be used without FSU IPC, or is that a prerequisite?
We need FSU IPC, but you do not have to have a registered version. So the free version that you can download from the website is totally sufficient for you to have full access to all the MobiFlight capabilities.
And how about Mac? Is it compatible on the Mac operating system?
Nope, not yet. No.
Okay, well I mean, we're going to talk lots more about MobiFlight, I'm sure, next week as well. Thomas, I think, sorry if I pronounced your name wrong, on the MobiFlight YouTube channel says for DCS, there is a DCS BIOS open source project. Can you talk about that, or do you know anything about that?
No, but I believe that's the interface basically that also kind of allows to access and get data out of DCS and also get data into it. So MobiFlight would have to have something that would be compatible with that. And MobiFlight is built in a way that you can support different flight sim APIs. It's simply not, nobody has yet started to implement it for DCS. And I'm all doing this in my free time. So I cannot kind of make everything happen. But if anyone from the community is like really passionate about providing access to DCS, then just approach me and we'll figure it out. It's open source. You can have access to the source code and contribute to the community. That would be awesome.
And where can people find you, Sebastian?
Where they find me?
Yes.
They can either find me on our Discord server, or when it comes to coding, also GitHub is a great place where the MobiFlight source code lives.
Perfect. A couple other questions that are maybe a little more specific on the YouTube channel. So Sebastian, maybe I'll leave you to read through those and you can answer some folks as we wrap up here. They may be a little out of scope for today's discussion, but good stuff that people have been contributing about their setups and what they're doing. So if you don't get a chance to answer that, I'm sure they can also ask you in Discord, right?
Yeah, I just saw someone asking if I was available after this session on Discord, and I think that's a nice idea. So I will I will do that. I will just hop over to the Discord channel and then you can meet me at one of the voice channels.
Perfect. And do you guys want to just real quick preview what have we got coming up when we do this again next week on March 19th? I know we're talking MobiFlight. We're building this live. Do you want to give a quick preview to folks of what we can expect?
Sure. Yeah. So we'll be mostly, I can even pull up MobiFlight right now. I think I even have the configuration for it. Open Sesame. Yeah, right here. I have it's basically two rows right here, the flap servo row and the input row. So these, I think, these ones, copy of copy. Yeah.
The input flaps, copy, yeah.
Yeah, there we go. Now it's better. It's just one row right here. I was doing some like tinkering around, but we have an input row and then an output row right here. It's pretty simple. Basically, like, we're gonna walk you through the process.
I'm gonna be the puppeteer. I'm gonna be the puppeteer and drive you there. Like yeah. But Trevor, you're also going to show how to assemble
Yes.
all the 3D printed parts and kind of get everything in place. We're going to connect it to an Arduino, and then eventually we're going to configure it, and then you will see the magic happen when things start to move in in the sim, and the opposite way also then on your flaps hardware piece.
And that is
Yeah.
next week on March 19th. You can register for that for free to get that calendar invitation so you don't miss it at flightsimiassociation.com/webinars. Any last comments, Trevor, Sebastian, before we wrap up for today?
So this was very theory heavy. If you like this, then you will love the next session because it's going to be so hands-on and really a lot to see and in action. So I'm really looking forward to seeing you guys again. It was a blast being here tonight. It was really nice. Also, thanks to Trevor. He has prepared a lot good material. And thanks to the FSA and Evan for having us.
Absolutely. You got this, everyone.
Very good. Well, we'll see you next week, Saturday, March the 19th. Thank you so much to both of you for being on and to all of our wonderful audience for the questions and the comments. We will see you next week on March 19th. Good night, everybody.
Yeah, bye.
Bye.
Thanks, guys, on the chat. Bye.